Okay, this is an introduction to indices. So we are starting the basis of indices. The indices is very, very important in mathematics, just like a foundation of mathematics. So now we want to do a times a square. A square means a times a. A cubed means a times a times a. A raised to power 4 means a times a times a times a. This particular thing is different from a plus a. A plus a is 2a. Once you are adding, the coefficient is increasing. The coefficient of a is 2. What they mean by coefficient is, forget the big grammar, is the number that is attached to a, that is the coefficient. But once you are multiplying, the power is increasing. So you have a times a is what? A squared. So there is difference between these two things. There is difference between a plus a and a times a. So know the difference because students were interswitching these to each other. So if you have a raised to power 3 times a raised to power 2, as long as the base, what the laws of indices is telling you is, as long as the base are the same thing, laws of indices are equal. So it will be a raised to power 3 plus 2, which will give you a raised to power 5. As simple as that. So supposing we have the question like the division law of indices. So we're having a raised to power 5 divided by a raised to power 3. So now I want to solve it using indices as long as the base are the same thing. This divide will still change to minus at the power level. So it will become a raised to power 5 minus 3. This will give us a raised to power 2. That's all. So now suppose you are adding a raised to power 3 divided by a raised to power 4. Now, same thing, this divide will change to minus at the power level. So understand this step. So this one will give us a raised to power 3 minus 4. This will give us a raised to power minus 1. And now, suppose you are having a raised to power n divided by a raised to power n. This divide will change to minus at the power level. That's just the law. So it will just give us a raised to power m minus n. As simple as this. So suppose you have this question, you are given this kind of question, a raised to power n times a raised to power n. This is like a formula. You are using the power outside to multiply the power inside. Power outside, this another law, this is third law. You are using the power outside to multiply the power inside, so it will give you what? A raised to power n. And suppose you are giving something like this, a raised to power 2 open bracket for the power outside multiply the power inside. So give you a raised to power 2 times 4 will give us what? A raised to power 8. Same thing, suppose you are having a raised to power negative power 3. This is having invisible power 1. So it will still give you a raised to power negative power 3. And this negative power in indices, we'll still get down to the law, but let me just brief you on this. If you see anytime you have negative sign, this negative sign become 1 at the numerator. Then the a raised to the power of 3, which you have this minus become 1 at the numerator, and the top become the remaining will become a raised to the power 3. So this is the final answer of this. So according to the law, so let's write the question: a raised to power n times a raised to power negative n. Now, according to the law, times become plus at the power level. So we have a raised to power n plus bracket minus n close your bracket. So minus times plus is minus. Minus is stronger than plus in mathematics. So we have a raised to power m minus n. M minus n is equals to what? A raised to power 0. Anything raised to power 0 is what? Okay, supposing you are given this kind of question again. you're having a raised to power n times a raised to power negative n all over a raised to power n. Simply just don't waste your time. Use this one, cancel this. We have a raised to power negative n. And I just told you that this minus become 1 at the power level at the numerator all over a raised to power n is a law. It's not, you cannot just, it's just the meaning of this law. So you will be applying in solving other calculation. This thing you can do it in two ways. If you don't want to do it this way, you can still have a raised to power n times a raised to power negative n all over what? A raised to power. I'm repeating the question again. Watch. This thing now you can still apply laws of indices as a numerator, which will have a raised to power. This m become, this one become m plus negative n all over what? A raised to power n. Now, minus times plus is minus. So we have m minus n all over what? A raised to power n. So now, m minus n, this is m minus n. So this m minus n, this one will give us what? M minus n will give us 0. So this will give us a raised to power 0 all over a raised to power n. And we know that anything is a law, anything raised to power 0 is what? 1 all over a raised to power n. So the same thing as this is this is the final answer a raised to power. The same thing as this. I hope you understand. So supposing we are giving this kind of question now, we are having a raised to power 1 all over half raised to power 2 at the behind the bracket. So now you use the power to multiply power inside. It's a law. You use the power outside to multiply the power inside. So you have 1 all over 2 times 2, which will invisible one here. Which this one will 2 times 1. A raised to power 2 all over 2. 2 divided by 2 is what? A raised to power 1, which is a. Our final answer is a. That is all. If you are doing it in this way, you can still do it in solid way. In solid way, you in solid way, if you have this question in short form, you have 1 over 2 raised to power 2. Now, this only this one inside it return to root. So root a, sorry, root a, square root a, it has turned to solve. This will become square root a times these two outside. And these two outside can cut, this power can cut this power outside. So you will have a. You are doing it so you can do it this way, you can do it in short form. Same thing, they gave you this question. You have a raised to power 1 over 3 and 3 outside. Simply don't stress yourself, just use this 3 cancel this 3. It will just give you a. Same thing, they give you a raised to power 1 over n bracket. These are lots of indices. And so you can see say a raised to power 1 all over n times n. N cancel n, we have a. Or you can say cancel it from outside. This cancel this. You have your a. That's it.